Good morning, everybody. I'm Yishan Lee, and welcome to my presentation. Today, I'd like to talk about each energy that corresponds to different cyclohexane conformation. I'm going to focus on three main points. First of all, we will look at the characteristics of cyclohexane. Second, we will discuss the difference between the half-chair and chair form. And finally, I will explain the distinction between the twisted boat and boat form. If you have any questions during the presentation, feel free to interrupt at any time. So let's get started. Among all cycloalkanes, cyclohexane is the most stable. This is due to fewer ring strengths as all bound angles are close to 109.5 degrees than 120 degrees found in a planar ring. Therefore, the tetrahedral structure contributes to cyclohexane's stability. Additionally, cyclohexane has two conformations, the chair form and the boat form. I will explain more on this in the next two parts of my discussion. So moving on to the second point. As you can see on this graph, it highlights the importance of cyclohexane's different conformation and its energy. Let me expand on this part. This relates to what I was saying earlier. From left to right, the first conformation is the chair form, which has the lowest energy since there is no torsional strain. Second is the half-chair form, an intermediate state as the chair form transforms to the boat form. This process leads to the highest energy point since the footrest is planar with the side of the molecule. That concludes my second point. Let's turn now to the two boat conformations. The boat form can be imagined as the lower footrest of the chair folded upward. This conformation is suffering from torsional strain because of acquiescing bond. So this form has higher energy than the chair form as a result of flat pore hydrogens interfering with each other. Last but not the least is the twisted boat form. It's a slightly skewed version of the boat form. Consequently, it reduced the torsional strain by separating the flat pore hydrogens and minimizing the bond eclipsing. This reduction partially lowers the energy, which illustrates why each cyclohexane conformation corresponds to different energy level. So that brings me to the end of my presentation. First, I spoke about the properties of cyclohexane. Then we looked at the comparison between two chair forms. And finally, I explained the contrast between the two boat forms. Before we finish, I'd like to leave you with one final thought. The lower the energy level of cyclohexane, the more chance of existence. Thank you for listening.